Welcome everybody. Hi, this is Dr. Tobias speaking. Hi, welcome to a preparation session for our upcoming quiz in the course Production, Logistics and Transportation Management. This session is mainly for your questions regarding the quiz. So I see 9 students are already online. I started the recording, as you can see, and will upload the recording to Moodle as well. So my question to you, do you have already questions on the slides or questions regarding the quiz? Maybe you can unmute yourself and ask the question directly. This would be the easiest way. Any questions regarding the quiz, the course materials? Now is the time to ask. You don't need to be shy. If you are too shy to use the microphone, maybe you can use the chat function to ask your questions. So maybe let me highlight some things that are of importance for the quiz. Oh no, now my Zoom is somehow lagging. My Zoom is not really responding properly. I will leave the meeting and rejoin. I hope I don't kick you out by accident. Let me leave the meeting and rejoin. What the fuck? So now let's see and hope it works more reliable. There's one question from Ruba. Will you need Excel to solve some of the questions? Very good question. Though you went through the course materials already, Ruba. Very good. And yes, you will need Excel to solve one of the questions. So as you can see, one main part of this quiz will be the transportation problem. And in the slides, I also show you how you can solve this transportation problem via Excel and why you can set it up. And this is the course layout, the layout in Excel to solve this transportation problem. And it's also described in the textbooks. So please familiarize yourself with this. You can expect a question on this topic that you should solve, that you should enter in Excel on your laptop at home and then solve it via Excel. Does this answer your question, Ruben? So everything on Moodle in the section Transportation Management will be relevant for this quiz. And we have mainly three slide sets. Number 10 is called Transportation Management. Number 11 is Transportation Problem. And number 12 are extensions to the transportation problem. And as you can see, number 10 is a stronger focus on memorizing and being able to explain these issues that are discussed. Mainly we discuss transportation infrastructure and modes of transportation. This is also a topic that you can learn very well by means of the textbook. So you should read the textbook that is recommended here when you go through these slides. And the learning goals is you should understand what is a transport chain. You should be able to discuss advantages and disadvantages of the different modes of transport. What are the different modes of transport? Road transport, rail transport, sea transport, inland waterway transport, air transport, and pipeline transport. And you should be able to discuss key principles of transshipment terminals. You see, this is all very much based on knowledge and understanding. For this first part, there's not so much of calculation questions. And as it is recommended here and also available on Moodle, please check out the textbook. It is very important that you are able to learn from the textbook as well as from the slides and the videos. The slides and the videos may be able to set some highlights, give you a first rough orientation, but it's very important that you read the textbook yourself. Why is this important? Well, maybe for this course and for getting a good grade, of course, you need to know about the concepts that we discuss in this course. But from a more general perspective, it is important that you're able to process information from textbooks yourself, and this will be some skill that you will rely on the rest of your life. Yeah? This is somehow much more important than just this course. Yeah? You will need this in all your study life at GeoTech and in your working and familiar and private life, processing information without someone who explains it to you all the time. And therefore, I'm challenging you to do this type of exercises. Though the transport chains are discussed in this general overview of transport systems, we have a starting point, some sender who's sending goods to some receiver who should receive the goods, and then the goods are transported via transshipment points to the receiving. So think, for example, you order something from China to Oman, to Muscat in Oman, and then the sender uses the truck in the pre-carriage process to transport the goods from the factory in China to a port, for example, in Hong Kong. At this port, we have a transshipment operation, so we load the goods from the road onto the sea, from the truck onto a vessel. And then we have the main carriage. This is usually the longest distance in the total transport chain. And our ship sometimes later arrives, for example, in Sohar. And in the port of Sohar, we again have a transshipment operation where we load the goods from the ship onto another truck, and we continue with our on carriage and bring the goods to the receiver. So, and this is a very general concept for many transport chains, and you need to be familiar with this concept. Then we have some more terminology: combined transport, intermodal transport, etc. And we discuss in some more detail different modes of transport. This is mainly based on knowledge. And we have here, we distinguish 6 roads of transport. Of course, the inland waterway transport is not really important for Oman, but for other countries, this is of much higher importance. On the other hand, pipeline transport is very important for Oman, and for almost all the countries in the world, the road freight transport is the most important means of transport. We have some performance measurements, how we measure the performance of a means of transport, of a modes of transport. And you will see here as an example how important the different modes of transport are here for the European Union. And you see that more than 50% of the freight performance measured in ton kilometers is done via road transport, and air transport is only 0.1. This considers all the transport inside the European Union. But this gives you a good order of magnitude how important the different modes of transport actually are. We have some characteristics, how we can characterize the different transport modes. This is explained in more detail in the recommended textbook, so have a look at this textbook. And then we can characterize every mode of transport according to these characteristics. The road freight transport is, of course, the most important mode of transport. And we have other modes of transport as well. Here you see again, chapter 5.3 is highlighted for the different modes of transport, where you can find more details about this. Another big topic that is mainly based, a knowledge-based and understanding-based topic, is the different transport infrastructure that we have. And here, terminals and transshipment facilities are a main type of infrastructure that we have. Transshipment facilities connect different modes of transport. So for example, if we stay to the China import example, bringing some goods via a truck to the port, and then from the port to via ship to Oman, then the port is a transshipment facility. We connect one mode of transportation, road transport, with a different mode of transportation, the sea transport. But we also have transshipment facilities when the mode of transportation is not changed. So for example, we bring via ship goods to one port, and then in this port we unload the first ship and load the goods on a second ship. Then again, the port is a transshipment facility, and we do not change the mode of transportation. And these transshipment facilities are, of course, very important logistics facilities because they are crucial for the performance of overall logistics systems. The airport is another very important example of a terminal and transshipment facility. Again, this information is even more detailed in the textbook, and you see here some examples of airports and airport operations. And we have different roles of airports: regional airports, international airports, cargo airports. So the port in Dubai is clearly an international airport, and this airport has the role of a hub. Though many smaller airports have connecting flights to this big hub airport, and then we use this big hub airport to collect as many passengers as possible and bring these passengers to a different hub airport. And by following this model, we usually are able to reduce the transportation costs significantly. So you should be able to explain what is a hub airport, what is a regional airport, and what is a cargo airport. A cargo airport in Oman, we don't have a big differentiation between cargo airport and passenger airports, but in other countries, we have sometimes dedicated airports that are only used for cargo transportation, and other airports are mainly used for passenger transportation. One reason for this might be different permits. So in many big cities in Europe or the US, airlines are not allowed to start and land, to arrive and depart at every time of the day. So in many German airports, the planes are not allowed to fly during the night. And therefore, the airport can only be used during the day. The reason is that planes are very loud, and people that live around the airport, they want to sleep in the night, of course. So to protect their interest, airports are often not allowed to operate 24 hours a day. But there are some airports that have this permission, and they are often, let's say, in the middle of nowhere with not many people living around. And these airports are often used for cargo transportation. It is much more convenient to do it this way. So this first part about transport infrastructure and transport modes and transport systems. This is more about checking your knowledge. And the second part, the transportation problem, is more of applying your knowledge and doing some calculations yourself. It is very important that you recognize that the transportation problem, this describes a mathematical, this is a mathematical problem. It is not any transportation problem, any problem that we need to transport something, though this term is reserved for a very specific problem. And the transportation problem has always the form that is described in this set of slides. So you should be able to explain what the transportation problem is. You should know the differences between an objective function, a constraint of a model, a decision variable, a feasible solution, and an infeasible solution. And when you are given a small, simple, real-world problem, you should be able to create such a model yourself. And as I already answered in the beginning of this repetition, you should be able to enter such a model in Excel yourself and solve it via Excel. This will be very beneficial to you because you become more familiar in using Excel. At the end of the day, many companies later want you to be an Excel crack. So every additional knowledge that you can gain in Excel is very beneficial for you. And here we enter the transportation problem in Excel and solve it. Again, here we have a good description in the textbook of Namias and Olsen. This is also available via Moodle. And here the two chapters 6.3 and 6.4 are of particular importance. In particular, 6.3 is very important. Now we start with an example, a fish production and transportation example. Of course, fish production is very important for Oman. And what do we have here? Let me directly go to the drawing of this picture. We have, on the one hand, 3 factories that produce fish. And on the other hand, we have 4 demand nodes for markets, for final customers that have a demand in fish. The fish supply and demand is measured in cases. We measure it here in cases. So in the factory number 1, F1, we have 45 cases. In F2, we have 121 cases and 95 in F3 cases. So the transportation problem is now characterized that the supply on the left side, that is drawn on the left side, the total supply on the left side is equal to the total demand on the right side. So when I add this up, 81 plus 78 plus 47 plus 55, it is the same number as when I add up the supply on the left side, 45 plus 121 plus 95. And now we need to decide how to fulfill the customer demand of these green customers on the right side, so that the total transportation costs are as small as possible. We want to minimize the total transportation costs and fulfill the demand of our customers. If we transport one case from F1 to A1, this will cost us 250 Baser per one case. If we do a transportation from F1 to B, it is more expensive. One case will cost us 420 Baser. And if we do a transportation from F3 to D, it is even more expensive. It will cost us 1,730 Baser. And now we have to decide how many cases we should send from F1 to A, B, C, and D, how many cases we should send from F2 to A, B, C, D, and how many cases we should send from F3 to A, B, C, D. This is the core of the transportation problem. And of course, we want to do this for the minimum cost. The interesting thing is that this problem is the core of many other more complicated transportation problems. So before we can solve even more realistic problems, even more challenging problems, we need to understand this more stylized and simple structure. And this is the reason why we spend so much time on this transportation problem. So now we build a model for this transportation problem. This is what we need to decide: the transport quantity from each factory to each warehouse, to each supermarket. And how do we represent these decisions in a mathematical model? For this, we introduce decision variables. And each decision variable in this specific model has two indices, I and J. And the index I indicates a factory. So in our example, the index I can have any of these values, F1, F2, F3, because, let me go back, we have 3 factories. And the index J represents our warehouses, and we have 4 different warehouses, A, B, C, D. So therefore, the index J indicates one of these 4 warehouses. And we write it in this generic way, Xij, to indicate the transport quantity from the factory I to the warehouse J. And then I can have these 3 values and J can have any of these values. For example, if we write X F2, C, it is 30. It means we transport 30 cases from the factory 2 to the warehouse number C. And since we can transport from every factory to every warehouse, we have 12 different decision variables. We have 3 factories and 4 warehouses, so we have 12 different decision variables for this model. Okay, that's the core of most of these models, the decision variable. Now, when you understand this decision variable, we can take the next step. So what are the consequences of our decisions? If we decide to transport cases from factories to warehouses, this results in certain costs. Now, how do we calculate the transport costs? And using our variables. Let me go back to the drawn example. You see, from F1 to A, we have transport costs of 250 Baser for 1 case. From F2 to B, we have 420 Baser for 1 case. From F3 to D, we have 1,730 Baser for 1 case. Now, we have all these 12 decision variables, and we multiply the transport cost for 1 case with the number of cases we transport from the factory to the warehouse. We have 12 decision variables, and for each of these 12 possible transport relations, we have different costs that are given. These costs are given from the beginning. And the last cost from F3 to D is 1,730. No, this is our function that explains how we calculate the total cost, and we are interested in the smallest possible value of these total costs. And this type of function, we call it objective function. This measures the consequences of our decisions and gives us an indication how good our solution is. So let's say we have these decisions from F1 to C, we transport 50 cases. From F3 to C, we transport minus 10 cases. From F3 to D, we transport 20 cases. And all the other relations are 0. Then we can calculate the transport costs in the following way, and we get to a total cost of 37 beta. Now, what is the problem with this solution? What is wrong with this solution? What do you not like about this solution? What looks strange at this solution? Any idea what's not fine with this solution? Look at the example data, look at the transport costs, at the total transport costs. What is the meaning of the decision variables? F1 to C, we transport 50 cases of fish. F3 to C, we transport minus 10 cases of fish. F3 to D is 20, means we transport 20 cases of fish from F3 to D, and everything else, all other transport relations are 0. Is there a problem with this data? Of course, when I ask this way, you can assume there is a problem, but what is the problem? Shoot, yeah, minus 10 seems a little bit strange. Yeah? Why is it strange, the minus 10? Yes, a transport quantity, you're completely right. Yeah. A negative transport quantity, what does this mean in the real world? Yeah, if we transport minus 10 cases, yeah, this sounds strange and does not make any sense in this context. For this model, it looks strange. So we are not yet done with building our model. There's another problem. So let me say, if we put the minus 10 here, of course, then we also need to put it here, and we have somehow a cost reduction. Yeah? Then this is just straightforward. The problem is that we have here a negative value in the beginning. And another problem that is more difficult to see if we only look at this small context, we could put 0 to, no, you mean the 0 that all the other transport relations are 0? Do you mean this as a possible problem, that everything else is 0? In this case, this is not necessarily a problem. It just means there is no transport. For example, we can decide there's no transport from, let's say, F3 to D. It looks very expensive, so let's try to avoid the transport. So 0 is a possible value, and this alone is not a problem. However, what might become a problem, we transport 50 units to warehouse number C and 20 units to warehouse number D. So that means in warehouse number D, we transported only 20 units, but D requires 55 units. So we do not fulfill the complete demand. Yeah. However, this was the reason why we started with this problem. We need to make sure that the demand of every customer warehouse is completely fulfilled. So the example solution does not make sure that each warehouse receives the required cases of fish. This is one problem in this example solution. Okay, we need more. We need to formulate, we call this restrictions on our decisions. So first of all, we need to write in mathematical terms that we only want to look at positive transport quantities. So we accept 0, our decision variable, the values of our decision variables have to be greater or equal to 0. We accept 0, they can have the value 0 or positive values. But it is not allowed that our decision variables have negative values. Yeah, the mathematical model has no idea about the real world. So we as managers, we as professionals need to instruct the model how it should work. Yeah? The computer or the model cannot do this for us. We have to tell the model that negative transport quantities are stupid. And you see, we again have this notation that we write that this should be true for all values of I from F1, F2, F3, and for all values of J, A, B, C, D. So actually there are 12 decision variables and each one should be bigger or equal to 0. This is the first thing. And we need to add more constraints. Yeah? And one constraint is a fish processing factory should ship everything it produces it cannot ship more than it produces. Yeah? This would not be possible. So let's look at the factory F1. Yeah? So we only look at the factory F1 now. So everything that is shipped from F1 is written in this first equation. So the shipment from F1 to customer A plus the quantity from F1 to B plus the quantity from F1 to C plus the quantity from F1 to D is 45. Why 45? This was our given data here. Yeah? We have 45 cases available and we need to decide how to distribute, how to allocate these 45 cases to our customers A, B, C, D. So we need to make sure that everything that we ship from factory F1, yeah, the total quantity added up is exactly equal to 45. Then we cannot ship more than 45 cases because we don't have more than 45 cases, and we also cannot ship less than 45 cases. Now, this equation describes the situation in factory F1, and we need to introduce the same equation for factory F2 and for factory F3. Okay. Now with these equations, we make sure that everything that is available at the factories will be delivered to our customers. But this does not make sure that every customer needs exactly the quantity that the customer requires. And for this reason, we need to introduce another set of equations. And now we look at one customer. We look at customer A, and we formulate X, everything that's coming from factory 1 to customer A, plus everything that is coming from factory 2 to customer A, plus everything that's coming from factory 3 to customer A is 81, because customer A requires 81 cases. And we formulate the same type of equation for customer B, for customer C, and for customer D. Now our model is complete, and we can write it up in this form. The first one is our objective function. We have here 3 types of constraints. We need to make sure that everything that is available on the supply side, on the factory side, is delivered to our customers. We also need to make sure that every customer receives exactly the required amount of cases. And we need to tell the models that we only accept positive transport quantities. The first part is the objective function. We call this constraints. The X was our decision variable. The values in front of the decision variables are the parameters of the model. Here we write min. We are interested in the smallest possible value. For other models, maybe we are interested in the maximum value. So we can write either min or max. For the transportation model, we are interested in the minimum total cost. And this would be our complete model. Now, a solution to this model means that every decision variable, every x, we have 12 x's in this model, every x is assigned a value. And the value needs to be 0 or bigger. Then we say we have a solution to this model. However, only if a solution meets all the constraints. So if we set in the value and all the constraints are met, all the equations are completely fulfilled, only in that case we say that we have a feasible solution. We say that our solution is infeasible if at least one of the restrictions is fulfilled, is violated. So for example, if we have a negative number for 1x, this constraint is not true and our solution would be infeasible. In the same way, if we set in the values and everything that is transported from factory 1 to our customers, if this is not equal to 45, again, we have an infeasible solution. And now we say a solution has minimum cost if it is feasible and if we are not able to identify another solution with smaller cost. In that case, our solution has minimum cost. And in the transportation problem, we are looking for a minimum cost solution where the factory supply equals the customer demand. That is the transportation problem. Here are some characteristics. We know the supply and the demand for each origin and destination, for each for each factory and each warehouse. In the transportation problem, the total demand equals the total supply. Each supply node is linked to each demand node, and the unit transportation cost, the cost for one case, for transporting one case from a factory to a warehouse, is known. We don't want to calculate this. This is already known. We want to decide how much we need to transport from a factory to a warehouse. So now here we have an example exercise. And this is the end of this slide set. In the next slide set, you see how to enter the transportation problem in Microsoft Excel. So if you prepare yourself for the transportation problem, it's always good to work with Excel at the same time, so you can try to improve your understanding. You can change the values here in this table. And you can make sure if you can also calculate the objective function yourself, and if you're able to prove that a given solution is feasible or not. I will re-upload this slide so that the text is better readable on this slide to make your life a little bit easier. We have also two extensions to the transportation problem. And these extensions are very well explained in the chapter 6.4 of NAMIAS. Yeah. Here in this chapter, the extensions are very well explained. And what you need to be able to do, you need to be able to understand the transportation problem, understand how to model the transportation problem, yeah, as it is here emphasized in the learning goals. And when there's a simple real-world problem given, yeah, like this fish transportation example, you should be able to write such a model yourself, and you should be able to use the Excel solver to calculate a solution to the transportation problem. Okay, that's from my side. Are there any questions from your side? Okay, no questions at this time. I wish you the best of luck for this quiz. And of course, the final exam, I asked RSA that we have the final exam in the lab. So we will have it similar to the logistics management course last semester, that you will be able to answer the questions in Moodle. And of course, the things that we discussed for the different quizzes will be then also very valuable for the final exams. I cannot promise that the questions will be the same. There will be some change, but I think studying for the quizzes, looking at the quiz questions, is always a good preparation for the final exam then later on. We have in total 4 quizzes, so this will be quiz number 3, and next week we have quiz number 4. And this is a good preparation for the final exam. because of course the things that I ask in the quizzes will be in the one way or another way also relevant for the final exams. Yes, the best 3 out of these 4 quizzes will be considered as your coursework grade. You're right, Ward. Okay. I wish you the best of luck for the quiz on Tuesday, 3 p.m. And see you then. Good luck. See you. Goodbye.